Good afternoon. Today I'll be discussing energy conversion in electromechanical systems and giving an example of an application on that conversion. We'll start with systems with motion, where we have a power source, a battery, and the resistance, a coil, and a ferromagnetic material with an air gap that can be closed by a plunger. Okay, so this system has two states. One where the plunger is not closing the system. This is an open system, and one where the plunger moves to close the system. We will realize that as current flows through the system, through the coil, part of the energy input is lost as heat in the resistance, but part is used to produce a magnetic field in the coil. Since the magnetic field produces a force on the plunger starts to move away from its initial position, closing the air gap. As the air gap is closed, the reluctance of the whole ferromagnetic core changes. It actually decreases. This means that the inductance of the circuit increases. This figure shows us the flux linkage plotted against current, and the slope of this graph actually shows us the inductance. So we realize that for a different position of the plunger, if the system is closed or open, the inductance differs. As the plunger moves to close the gap, as we said before, the reluctance will decrease, and thus the inductance of the circuit will increase. Therefore, we realize that the inductance of the system is actually a function of the position of the plunger. The result of changing the inductance as we move the plunger into the gap is the flux linkage changing, because the flux linkage is actually equal to the inductance multiplied by the current in the system. Therefore, we realize that the inductance of this circuit, the flux linkage of this circuit, is dependent on the position of the plunger and also the current flowing through the system. According to Faraday's law, as the flux linkage changes, the EMF induced in the coil also changes, and this change in the EMF induces another magnetic field of opposing effect, means it will be opposing the movement of the plunger. This system can be change can be expressed in a mathematical model that will be shown next. We will start by expressing the voltage balance equation, which is the heat dissipated in the resistor. The V input is equal to the heat dissipated in the resistor plus the induced EMF, the back EMF. But as we just said, lambda, the flux linkage, is a function of X and also I. Therefore, we can express this equation as follows: Vn equals IR plus partial d lambda by di into di by dt plus partial d lambda by dx into dx by dt, multiplying both sides by I and dt to get the energy balance equation. And comparing this equation, this differential equation, with the energy differential equation, we'll find that the V input can be expressed as Vn I dt. The ohmic losses can be expressed as I squared R dt, and the energy and the field stored energy can be expressed as a function of flux linkage and I only. I d partial d lambda by di times di, and mechanical stored energy as I d lambda by dx, partial d lambda by dx multiplied by dx. My application is going to be a linear actuator or a linear engine. The components we'll need for the prototype is an iron nail, a long iron nail, a contact switch, three pieces of magnets, a hollow copper solenoid, a hollow copper coil, and a metallic spring. This is my prototype assembly. This is where the contact switch is placed. This is the battery. This is the iron nail. It is fitted inside the copper solenoid. This is a metallic spring. This is a piece of magnet attached to the head of the nail, and this is a piece of magnet attached to the end of the nail, and this is another piece of magnet attached to one end of the contact switch. I will now explain how this linear actuator works. Once the circuit is closed initially, current flows through the coil, producing a magnetic field in the direction of the solenoid center line. Only in the instant when the contact switch is closed initially, the magnetic field produced then acts on the nail, because it's an iron nail, pushing it towards the contact switch, moving linearly. It makes the nail move linearly towards the contact switch. As the end of the nail where the piece of magnet is placed approaches the piece of magnet on the contact switch, both magnets repel, allowing the spring to pull the nail in the opposite direction. It pulls the nail back, returning it to its initial position, and at the same time the repulsion causes the contact switch ends to come in contact, closing the circuit again and producing an instantaneous magnetic field that will start the motion over. Therefore, the nail will keep moving back and forth, closing and opening the circuit instantaneously. And this is how a linear actuator actually works. Thank you for your attention.